Welcome students to the 8th video module. Now the topic is determination of rigidity modulus of the material. We learned about rigidity modulus and couple per unit twist in the 7th module. Now it is an experiment to determine the rigidity modulus actually. There are two experiments. The first one is static torsion experiment. The apparatus consists of a long rod which is clamped at one end and the other end is clamped to the center of a large wheel which can rotate, and a weight is attached to a string to the wheel. Because for twisting the long rod we have to apply a force. If we apply a force, there is no way to measure the force. So what we do is we hang a weight so that the force is a measurable quantity now. So if we apply a force mg at a distance r from the center of the wheel, then the moment of twisting couple is force times distance. You can see in the picture, it is force is mg and the distance from the center is r. So w times r. Weight is mg, so mgr. And the moment of torsional couple set up inside the rod is pi eta r raised to 4 theta divided by 2L. This expression we already derived in the 6th module, where eta is the rigidity modulus of the material. So the moment of twisting couple due to external force mg is mgr, and the couple that develop inside the rod is pi eta r to the power 4 theta by 2L. In equilibrium, mgr equal to pi eta r to the power 4 theta divided by 2L. Solving this, we get the expression eta equal to 2 mg r L by pi r to the power 4 theta. How we get the value of theta? The value of theta we can directly read from a pointer attached to a scale. You can see the pointer attached to the rod and there's a scale. So we'll get the angle in degrees. From degrees we can convert that into radian by the equation pi over 180 times theta. The angle in degrees equal to pi in radians. Substituting that value, we can find the value of modulus of rigidity using the equation eta equal to 2 mg rl by pi r to the power 4 theta. Capital R is the radius of the larger wheel and small r is the radius of the rod. This is the first experiment to find modulus of rigidity. Now we can use another experiment, that is torsional pendulum. A torsional pendulum consists of a long wire which is clamped at one end, and the other end consists of a mass which is normally in the shape of a disc. Now when we apply a force, then the torque developed in the string is given by tau is equal to c theta. The work required for a small deviation d theta is given by dw equal to tau times d theta. Tau is replaced by c theta, so c theta d theta. The total work done for rotating it from 0 to theta degree is w equal to integral 0 to theta c theta d theta, that is equal to C is a common factor, can taken outside. C, the integral of theta d theta is theta square over 2. This work done will be stored as the potential energy. When the external couple is released, due to this stored potential energy, or the potential energy converts to kinetic energy. And what is the expression for rotational kinetic energy? That is half I omega square. So whatever the amount of potential energy reduction, the same will be added up to the rotational kinetic energy, so that the total energy is a constant. That is, the potential energy plus rotational kinetic energy is a constant. Now the rotation omega, half I omega square, omega can be replaced by the equation. We know that angular velocity is equal to d theta over dt, rate of change of angular displacement. Now again differentiating this equation, half c times the differential of theta square is 2 theta d theta by dt, plus half I times the differential of d theta by dt square is 2 times d theta by dt times d square theta by dt square, equal to constant. Or we say equal to 0, because the differential of a constant is 0. So the differential of this quantity will be equal to 0. Now d theta over dt can be taken outside. Therefore the expression become d theta over dt times c theta plus I d square theta over dt square equal to 0. Taking d theta over dt to the other side, we get d square theta over dt square plus c over I times theta equal to 0. That is similar to the expression that we already learned in the lower classes, that the expression for a simple harmonic motion, what is that? D square theta over dt square plus omega square theta equal to 0. Comparing these two equations, you compare, the first term is d theta over dt square, here it's this d theta, d square theta over dt square, and the second term is c over I times theta, and here the second term is omega square theta. Comparing these two equations, what is omega square? Omega square equal to c over I, and omega the angular velocity, that is omega equal to root of c over I. But we already know omega is 2 pi over t. So 2 pi over t equal to root of c over I. Simplifying this equation, time period of oscillation of the torsional pendulum t equal to 2 pi times root of I over c. Now we know the expression for c, the torsional constant, as pi eta r raised to 4 by L. Substituting and simplifying for eta, the rigidity modulus of the wire is given by 8 pi I over r to the power 4 times L over t square. So all these are known quantities, and we can find the value of rigidity modulus of the material of the wire. Thank you, students.